Hello dear students, hope you all are doing well. I'm Nabi Hassan, your chemistry teacher, and today I'm going to start a new chapter. The name of the chapter is Solution. Now to start with, let us first try to understand what is meant by solution. Solution is defined as homogeneous mixture of two or more components, or we can say substances. So let us try to understand what is meant by homogeneous. Homogeneous means uniform composition. Let us take an example. Let's take a glass of water, and to this glass of water we'll add a spoon of sugar. Now when we add the sugar in water, sugar will get dissolved and will result in solution. Now here, if you taste this solution, whether you taste from this side or from this side or from any part of this solution, you'll get the same taste, which means the amount of sugar and water is same throughout. It's having an uniform composition. So this is homogeneous. So in solution, you should have a homogeneous mixture. Like you have taken your sugar and water. So we have two components here. We can have more than two components. Now, if we take two component system, the components are solute and solvent. Now, solute is the one which gets dissolved, whereas solvent is the substance where solute will get dissolved. Now say for example, in this solution you have water and sugar. So sugar will get dissolved in water. So sugar is solute and water is solvent. Next, let us see the types of solution. So based on the physical state of solvent, they are classified as solid solution, liquid solution, and gaseous solution. So this classification is based on the physical state of the solvent. Now if the solvent is in solid state, whereas solute can be solid, liquid or gas, the solution is known as solid solution. Similarly, if the solvent is in liquid state, solute can be solid, liquid or gas. The solution is known as liquid solution. And if the solvent is in gaseous state, the solution is known as gaseous solution. You can take the example of the sugar solution. So you take a glass of water, you add a spoon of sugar here, so you will get sugar solution. Now in the sugar solution, the solvent is water, and water is in the liquid state. So this is a liquid solution. Similarly, if the solvent is solid solution. If the solvent is gaseous, it's gaseous solution. Next classification is aqueous solution and non-aqueous solution. Now, in aqueous solution, the solvent is water. Whereas in non-aqueous solution, you take any other solvent other than water. So in aqueous solution, if you take the solvent as water, it's known as aqueous solution. You take any other solvent like benzene, chloroform, any other solvent except water, the solution is known as non-aqueous solution. Next, concentration or strength of solution. Now, concentration or strength is to find the amount of solute in a solution. Say, for example, you have taken two different glasses, say this is glass A and this is glass B. In glass A, say you have 100 ml water. In glass B, also you have 100 ml water. Now in glass A, you add 1 spoon sugar. Whereas in glass B, you add 2 spoons sugar. Now you'll find the amount of solute in glass B is more than the amount of solute in glass A. So we can say the concentration of solution formed in glass B is more than the concentration of solution in glass A. So what we are going to do, we are going to use different terms to express the concentration or strength of a solution. So the first term to express the concentration or strength of a solution is mass percent. W by W. Now mass percent is equal to mass of the solute by mass of solution. And since we are going to calculate the percent, that means percentage, it will be multiplied by 100. So when you are calculating mass percent, in numerator you have to write the mass of the solute, and in denominator you will write mass of solution. Similarly, we have a volume percent. V by V. When you calculate volume percent, in numerator you will take volume of the solute, and in denominator you will take volume of the solution. And since you are going to calculate percentage, it will be multiplied by 100. So you can find a similarity if you are taking mass percent is mass of solute by mass of solution. If you are taking volume percent is volume of the solute by volume of the solution. Say for example, 10% by mass. If you have a solution whose strength is 10% by mass, it means you have 10 gram of the solute in 100 gram solution. Say you have 20% by volume. The strength of a solution is 20% by volume. It means you have 20 ml of solute in 100 ml solution. So it's always expressed in terms of solute and solution. So if it is mass percent, mass of the solute by mass of the solution. If it is volume percent, volume of the solute by volume of the solution. Let us take a question from mass person to understand it better. So the question is, calculate the mass percent of ethanol if 20 gram of ethanol is dissolved in 140 gram of water. So if you read the question carefully, you'll find ethanol is dissolved in water. So the one which is dissolved is solute, and where it is dissolved? In water, so water is solvent. So it's given mass of solute, that means mass of ethanol is equal to 20 gram. Mass of the solvent you have to find, because here is ethanol and water. So mass of solution is equal to mass of solvent, that means mass of ethanol plus mass of the solute. Mass of solute, that is mass of ethanol, and mass of the solvent, that is mass of water. So it's given mass of ethanol 20 gram, mass of water is given 140 gram. So therefore the mass of solution is 160 gram. So therefore mass percent is equal to mass of solute, that is 20 gram, divided by mass of solution, that is 160 gram, multiplied by 100. So if we simplify this, so it's 50 by 4. So it's 12.5%. Let us see the next concentration term, which is molarity. So molarity is defined as number of moles of solute per liter solution. Mathematically, is represented as capital M, which represents molarity. Molarity is equal to number of moles of solute, that is NB, where B means solute. You can take A as solvent and B as solute. In some textbook, instead of A, they use 1. Instead of B, they use 2. So 1 or A means solvent, 2 or B means solute. So B here means solute, N means number of moles. So NB is number of moles of solute by V. V means volume, volume of solution, and it should be in liter. Or you can write NB by V and you multiply here by 1000. Now if you multiply here by 1000, you can use volume in terms of milliliter. Now if you modify this formula, we know NB, that is number of moles of solute, is equal to mass of solute by molar mass of solute. So in place of number of moles of solute, we can use mass of solute and molar mass of solute. So you'll get WB by MB multiplied by V. So this is the formula of molarity. Now here, V is volume, which is temperature dependent. So therefore, molarity is temperature dependent. So let us take a numerical from this topic. Calculate the molarity of a solution containing 4 gram of NaOH, that is sodium hydroxide, in 500 ml solution. So remember this, whenever you are doing a numerical, always write down the formula first. So we have to find molarity, so we'll write down the formula of molarity. That is M, capital M, is equal to WB by MB multiplied by V, and is multiplied by 1000. Now, since the volume is given in milliliter, I have multiplied here by 1000. So first, read the question and find out the variables given. Calculate the molarity of a solution containing 4 gram of NaOH in 500 ml solution. Now here, the solute is NaOH, that is sodium hydroxide, and is given 4 gram of NaOH. So mass of the solute is 4 gram. That is WB equal to 4 gram. MB, that is molar mass of solute. Since the formula is given, that is NaOH, we can easily calculate the molecular mass or the molar mass from the formula. So we know sodium atomic mass is 23, plus oxygen is 16, hydrogen is 1 gram per mole. So the molar mass of NaOH is 40 gram per mole. Next, volume. V is equal to 500 ml. So we'll put these variables in the formula and we'll simplify. So if you simplify, you'll get 0.2 mole per liter. So in the next video, we'll continue this chapter. Thank you.